What is the Internet of Things? We can start by taking a look at a single sensor, say a Wi-Fi connected refrigerator. It can read and send its internal temperature to whatever needs the data through the internet. But when we have thousands, millions, or even billions of refrigerators, cars, and even medical implants, it becomes a giant network of devices, all communicating massive amounts of data. This is what we call the Internet of Things.
If you look at from any IoT solution, it has four workloads. You need to cover rapid ingestion, you need to talk about take care of real-time alerts, real-time reporting, and then predictive analytics. You don't have one solution which is going to bring all these together. So there are silos and there's a lot of data movement. Here in this, the solution we put together in Esgyn, it has one place you can take care of all these four workloads together.
Earlier, we built a functional server and dashboard that can take IoT sensor data and store it into EsgynDB, as well as provide real-time alerts and analytics on the data. But in the real world, IoT devices produce large amounts of data, and many business owners demand real-time monitoring and quickly generate reports whenever those devices fail. That's why we are using EsgynDB, as it is powerful enough to support rapid and massive data ingestion, and is efficient in providing real-time and predictive analytics on the data. Instead of just a collection of sensors, which is what we had before, we wanted to show an important use case for this solution.
Let us review some real customer deployments of EsgynDB to demonstrate how bringing together these varied workloads onto a single EsgynDB platform can solve real-world problems. We have three customer use cases to show you: an online internet security provider, a vehicle surveillance system, and a public transportation agency. In the case of WebRoot, we have 60 million protected devices which are generating large amounts of data every day. These feed into Amazon S3 storage services. EsgynDB is continuously ingesting this data and provides rapid response to ad hoc queries from thousands of customers, all on a single platform. Here we have a vehicle surveillance system in China, whereby license plates are captured and driver facial recognition is performed at toll booth lanes across the province, with huge amounts of data continuously fed into EsgynDB. Over 2,000 operators are active on the system concurrently, running a variety of reports and analyses, checking for fake or duplicate license plates, and searching for criminals and so on. Real-time data coupled with fast response times are critical success factors for this customer. And finally, for a transportation agency in China using real-time monitoring coupled with predictive analytics, we have a fleet of 180,000 buses generating 500 million events per day. These are continuously ingested into EsgynDB. Over 400 operators are able to query the data in real time with sub-second response times and with a latency of less than 10 seconds from event generation to the availability of that data for queries. This is a perfect example of mixed workloads on a single EsgynDB platform, with transactional inserts, near real-time queries, and aggregations performed on incoming event data.
This entire process boils down to four problems: massive data ingestion, real-time alerts, real-time analytics, and advanced predictive analytics. With currently available solutions, handling all four problems is a big mess. Some solutions are good at data ingestion, but are terrible with analytics. Some can give real-time alerts, but can't hold the data long enough for predictive analysis. Putting these solutions together end up with data being moved around needlessly, resulting in higher costs and more headaches when something inevitably goes wrong. Here at Esgyn, we've developed a solution that can handle all four of these workloads with ease.